Well, good morning, everyone. I'd like to get started here. This is turning out to be an annual pre-TPRC bash for us. We did one last year. I think we're going to start with mimosas next year to get everybody in the right frame of mind for academic policy conference. Those things are pretty wild, I understand. Is that right, Chris? They're crazy. Academics go wild here. So anyway, on a more serious note, really, I want to welcome you to, I'm Rob Atkinson, by the way, ITIF. I want to welcome you to Bennett on Managed Services, and we will adjourn probably a little bit before 12. I'll go down the line here and introduce everybody in a second, but let me just make a couple of framing remarks. You know, looking at the net neutrality debate, which I guess is maybe going on 9 years or so, and maybe 5 years in earnest, it seems that it keeps going through this evolutionary phase where we started off with everybody's major concern being about blocking and degrading of Madison River, and then evolved into a concern about charging and being able to pay extra for quality. Then we sort of merged into a debate about network management and carrying through that. And now, sort of the next big issue seems to be this question of managed services. In other words, should we be able to have the internet do more than one thing, which is the best efforts? Delivery can actually be also doing a different kind of quality of service. And it's interesting because a lot of people have talked for the last decade or so about convergence and how everything's converging around IP-based networks, and yet internet and IP protocols on the internet, and yet we seem to be saying, wait a minute, in this area we really don't want convergence. We don't want one network to be doing multiple things with different protocols. We want that to be separate. I think it's an interesting tension that we have, that some people are saying, yes, there's convergence, but we really don't want convergence. So today we'll talk about this question of managed services. What is it? What are the policy questions we need to think about, and what are the risks, if any, of it? So I'm going to start. I'll start here on my immediate left, introducing Richard Bennett. Richard is senior research fellow here at ITIF, focusing on telecom policy. He specializes in broadband networking and internet policy. He has a 30-year background in network engineering and standards. He's vice chair of the IEEE 802.3 task force to devise the original Ethernet hub standard. He's contributed to Wi-Fi standards for 15 years. He's also active in OSI and the instigator of the RFC 1001, which I know you're all familiar with. And he's the inventor of the distributed reservation protocol for ultra-wideband. Needless to say, Richard is a real engineer, unlike me, and has had a long background in this area. Christopher Yu is a professor of law and communications at Penn Law School. His research focuses on economic theories of how economic theories of imperfect competition are transforming the regulation of the internet and other forms of electronic communications. He's been a leading voice in the net neutrality debate in the last several years. He's also the author of a book with Daniel Spolver called Networks in Telecommunications, Economics and Law, which was a Cambridge 2009 book. And he also testifies in front of Congress, the FCC, and the FTC. Chuck Jackson is an adjunct professor of electrical engineering at George Washington. He's also a consultant. He teaches courses on mobile communications, computer networking, security, programming, and other areas. He is also a digital designer and system programmer, has a long background in consulting in these areas, and has also served 3 terms on the FCC's Technological Advisory Council. Hank Hultquist, oh, sorry. Hank? Scott, I missed you. Scott Jordan is a professor of computer science at UC Irvine, and his research interests include communications policy, pricing and differentiated services on the internet, and resource allocation in wireless multimedia networks. He is also working on net neutrality and traffic management. He received his PhD in electrical engineering and computer science from UC Berkeley. He's also served as an IEEE Congressional Fellow, worked in the U.S. Senate on Internet Telecom Policy and on the FCC Open Internet Technical Advisory Committee. Now we get to Hank. Hank Hultquist is the Vice President of Federal Regulatory Affairs for AT&T. He joined AT&T in 2004 when the SBC portion of it. He's a board member he's a member of the board of directors of the Wireless Communications Association International. Also serves on the North American Numbering Council. Prior to AT&T, he was at MCI for 8 years as a graduate degree of George Mason School of Law. Elijah Krigman is a reporter from National Journal. She covers technology and telecom issues there. She has not, I think, developed internet standards yet, but she's working on that in her spare time. But she covers these issues extremely well. I think we've all read her work and benefited from it. She's also spent 2 years at the Brookings Institution and was also worked at the U.S. Embassy in Buenos Aires. She received her bachelor's degree from University of Wisconsin and has published in the among numerous areas, numerous publications, including the LA Times, the Atlantic, the Examiner, and other places. So I want to welcome Eliza. So we'll get started with Richard kicking us off.
Hello, everybody. Thanks for coming out. The controversy about managed services and differentiated services is okay, it's just not. Okay. Yeah. All right. So there's a technical issue in internet networking protocols regarding differentiated services and managed services that's reflected in the policy controversy about exactly how to write an anti-discrimination provision in a net neutrality bill. One of the things that I find kind of remarkable about this is that every time I see a draft of a proposed congressional regulation or act of Congress addressing net neutrality, the approach that it takes to the anti-discrimination provision is different than it was in all the previous bills. And I think it kind of reflects, you know, the dynamism or the lack of understanding, perhaps even in the network engineering community, about the differentiation problem. And it's an old argument, actually, in network engineering back in the 1970s. We had heated discussions about, when we were building local area, the first generation of local area networks, whether to go for networks that were just dumb fat pipes or to put management in a network. And it was a crucial question back then because we had a shortage of gates to work with. And so you literally couldn't build a network that was both extremely high capacity and extremely well managed. You just had a limited number of transistors to work with, and you had to make that trade-off. And I think part of what's behind this also is the FCC's fears that, you know, because wireline, every customer of a wireline broadband network essentially has to deal with a monopoly situation in its first hop, there's potential for abuse there. Now, just to sort of go into the internet's history a little bit, without belaboring it. Originally, you know, the internet, the internet's actually doesn't have an opinion about differentiation. Because differentiation is certainly in the initial design was a property of the networks that the internet interconnected. The internet isn't now and never has been really a network, right? It's a means of internetworking and interconnecting networks. So consequently, many of the important questions of networking, certainly in the original formulation of the internet protocols, were not addressed by the internet architecture or the internet protocols themselves. They were deferred to the networks. So ARPANET had two different grades of service. It had an interactive grade and it had a bulk data grade. And the internet has no opinion about that, but when connecting ARPANET to one of the other constituent networks of the internet, the San Francisco Bay Area Packet Network, which also had two grades of service, an interactive grade and a bulk data grade, what it endeavored to do was to allow ARPANET applications that relied on having the interactive grade of service to connect to the interactive grade of service on the packet radio network. And the means of doing this was a type of service field in the IP header, which was initially 8 bits long. And you can go into the history of the Internet protocols in RFC 795, which was written back in the 1970s by John Postel, talks about how the bits in that field map to the service qualities in the different networks. So that's kind of the way that the Internet initially dealt with differentiation. So after the commercialization of the Internet in 1995, then the question of charging for differentiated delivery services became a live question. In the academic days, there weren't bills being passed back and forth. I mean, money wasn't being exchanged, so it wasn't an issue. But it became an issue with the privatization of the Internet and the decommissioning of the NSF backbone. And that's when we started to see an awful lot of work in the Internet Engineering Task Force in the form of the RFCs that proposed different ways of allowing Internet backbones to actually, because there weren't any backbones in the original phase, right? In the very early days, ARPANET connected to Packet Radio Net to a gateway. There wasn't any backbone. To the extent that there was any, that was just ARPANET was the backbone. So when we had, Internet core transit networks who were charging fees for their use, as they always have, then the question of pricing and being able to sell differentiated transport services became a live question. We started, and there's an awful lot of really amazing academic work that was done in the late 90s on this. It's reflected in the RFCs, and it's still an ongoing area of active research within the Internet community. So one of the things that I think causes a lot of confusion about differentiated services and the sort of the all packets are equal concept, which is behind a lot of the net neutrality thinking, is that there's a difference between the way the Internet might work in theory and the way it works in practice. And the way it works in practice is actually, in the United States anyway, probably 99% of the packets that go across the Internet are all at the same rate of service at best efforts. And it's largely because the privatization happened so quickly that the protocol BGP had to be invented, and it was just getting all of these networks to interconnect without the NSF backbone was so traumatic that the question of interconnecting and then preserving all this differentiation just really couldn't even be addressed. So the current operational norms, which are still mostly under NDA, do in some instances permit the passage of packets between networks at different grades of service. It's more common in Europe than it is in the United States, but it certainly happens. And so what the Internet is a network that's differentiated in theory, but best efforts in practice, and is not necessarily always going to be that way.
You gotta kind of watch the slide. I don't think that's
Yeah. Okay, so where I want to be is why differentiate? Okay. So, and the reason I think probably it's stated best in RFC 2475, we want to differentiate networks because applications, after all, are the thing that really drives how the network should behave. The network should be a vehicle, especially a converged network has to be a vehicle for all the applications. So when you have applications that require a really low cost service, like peer-to-peer distribution of large files, and you also have applications that require extremely low delay delivery, like voice over IP or immersive video conferencing. In order for those things to thrive on the same network, there has to be some differentiation. So, and in fact, MPLS, which is kind of the hidden protocol that nobody really talks about, nobody really seems to understand much about, that actually makes the Internet work, was designed, to include a bunch of traffic engineering capabilities, and in fact, Internet carriage is one of those things. So there are some good reasons to forbid differentiation. which I think we've all heard about, to essentially protect ISPs from the temptation to misbehave. And there's also a desire to, if we forbid differentiation, we'll focus more on the deployment of raw bandwidth, which isn't necessarily helpful for wireless users. But, sort of what it comes down to is a question of angels and devils. I mean, there are things that differentiation can provide for you. There are upsides, there are downsides, and it's a question of whether the upsides are better or greater, add up to more than the downsides do. And classically, networks have always been differentiated in terms of the applications they support. And the role of managed services, I think, is kind of one way to illustrate that is through the evolution of the telegraph network into email. When the Morse code key was replaced by things like by the teletypewriter, then you didn't have to have a skilled operator on a privately owned network anymore. And so telegraph very quickly, sort of evolved into telex, which was basically a precursor to electronic mail, where people could send business communications to other businesses through an exchange that was run by Western Union called the telex exchange. And that eventually, I think, evolved into electronic mail. And in fact, when the ARPANET was first deployed, these teletypewriters, like this teletype ASR 33, these were the terminals that were actually connected to the computers that were on the ARPANET. And so the command line interface, was implemented through the keyboard and the printer on these things. Oh, and by the way, this little thing on the left, the paper tape, that's the file system, right? And so in 1920, right, we had applications on the telegraph network that were combined interactive use through the keyboard and bulk data file transfer. And so, I mean, things haven't really changed that much, have they? But networks have been engineered to interleave and sort of balance resources between these interactive applications and bulk data applications as long as they're in digital networks, literally. And it's differentiation in the network that permits that to happen. And so obviously, coming up with a workable anti-discrimination rule that permits, differentiation is a constructive step, I think, going forward. We just need to figure out how to do it.
Well, thank you, Richard, for organizing this, and to ITIF and Rob Atkinson for doing this. This is a fabulous event last time, and it's a great event this time. Happy to be here. What's interesting is, first I need to correct one thing Rob said. I have a new title. I'm actually now a professor of computer and information sciences. And it reflects sort of a new direction that the work I'm doing, because it's interesting. I mean, my first cut at this has been largely because of a frustration that much of the internet debate, many of the people in it don't have a background in regulated industries. They take it from the industry, they come to the internet as if it's a new day, and they don't really, and they make a lot of basic mistakes. I still remember I was testifying from the FTC. One of my co-panelists on network neutrality, who I won't embarrass by naming, looked at me after the end of this presentation, my presentation, and said, "This Ramsey pricing thing, that's really interesting. Did you write about that where I could learn some more about it?" And there's a powerful lack of history involved in many of the participants in the debate. And if you ask me privately, I'll even embarrass them by telling you what's going on. The second thing, though, is the chart of the work now is really focusing on what I'm discovering is there's a lot of basic engineering principles that the economists who have dominated much of the debate don't understand. That in fact they're afraid of the engineering, the underlying technology, and there's a lot of very, very simple concepts that are very well accepted and well understood in the engineering community, either as a conventional wisdom or as an active part of the debate, which are kind of being glossed over. So I actually want to just do two things. One slide quickly, and one is to sketch out some of the history of this and to show you exactly how this has been, and then I'll actually talk about some specific examples of managed and specialized services so you can get a flavor of what's going on. In fact, the different means for prioritization have been part of the internet since the very beginning, and have been an active source of research, as Richard said, throughout since the mid-90s. So for example, there is a type of service flag designed into the IP header from the beginning on purpose specifically to enable different networks to prioritize, originally between interactive and bulk transfer networks. And second, there's integrated services which allow you to essentially set up virtual circuits to reserve resources in advance. That was developed in '94. Differentiated services don't give you prioritized service. That's an ITIF standard developed in '98. And again, it can't guarantee you throughput. Prioritization just probabilistically increases the likelihood that you'll get through quickly, but it doesn't provide the same sort of support that integrated services does. Explicit congestion notification, I think, was 2001, where you're actually getting information from the core of the network. One of the classic problems with congestion is congestion depends on what multiple users are doing at the same time. You cannot determine what the impact of congestion is based on what you're doing by yourself. It's a matter of what I'm doing, what Richard's doing, Chuck's doing, Scott's doing. And if I'm using the network very heavily at a time where no one's using it, I'm not causing congestion. Even if I use a tiny amount of bandwidth at a time when everyone's using it, it can cause a great deal of congestion. So this is a joint problem. And the problem is that the end users don't have the information to understand how to optimize it. So explicit congestion notification is a way to bring that to the surface. There's actually a new proposal being pushed called re-ECN, which then brings it back through the network to bring it back to the routers to allow them to optimize that in a better way. Richard mentioned multi-protocol label switching, MPLS. It is a technology that's very important, very badly misunderstood, even by computer scientists. Because what you'll discover is many people working the internet layers, which are layer 3 and above, when you start talking about the lower layers about how the networks actually route, they get extremely intimidated and they stop talking. And one of the nasty little secrets about MPLS is that Richard's talking about differences in services and that different services need different things. There is a conventional wisdom understanding that, connecting to more points in the network inherently is better. What MPLS is about, and it's something that I'm pushing in my work lately, is that in fact, not all endpoints are created equal. I don't value access to raw size of the network the same. I disproportionately go to a handful of websites. Number one, my remote desktop access from my home to my office, my email server, my file server, a handful of websites. I spend too much time on ESPN.com. All these, but the answer is I really value about 20 sites, 20 locations, much more highly than all the others. And in my case, I would willingly trade off a certain amount of performance to all the other sites to get a better connection to my office through remote desktop access. What you start to realize is not just differentiating among services, it's differentiating among locations. And then the last one is a return to this idea of bulk transfer. This is a new initiative going through the ITIF called LEDBAT. LEDBAT basically is worse than best efforts routing. It's not, if you're trying to send a service, it's not even going to compete. It's going to get out of the way if there's any traffic on the network. So if you're backing up your computer online, if it shows up at night, if it happens over a span of 2 days, you don't care. And it's a great way to clean out the network and allow you to do these high bulk, low priority applications in ways that don't interfere with the network. Now, if you want some interesting examples of how the rubber hits the road, I'm going to give you 7. I probably won't get through all of them given the time, but my favorite one actually happened in 1987. When the PC developed, before the PC developed, it was basically people sitting at keyboards keying in keystrokes at a very slow rate. Once you could hang a computer on the network, you could actually transfer files. And in fact, what happens is it greatly spiked the usage on the NSF net. So what happened was the terminal sessions, when someone's sitting at the terminal, they're typing, they slowed down to a crawl because they were competing with the file transfer set. What did the NSF net do? It prioritized terminal sessions where someone's sitting there at the keyboard over file transfer sessions. Why? No one expected a file transfer session to happen. They expected it to happen over minutes. There's no one sitting there waiting. Unlike in the terminal, where if you're waiting a 10-second response or even a 2-second response for every keystroke, it makes it virtually unusable. So they prioritized a certain kind of application over another just to make it work for consumers. One of the great proposals, John Keehaw has a proposal for secondary markets and spectrum on cell towers. If you have a cell phone usage that's going below market, that's not fully utilized, resell the service to someone who can tolerate much lossier service, dropped calls, lower quality service, but it's as long as they can preempt it when the primary user needs it, it makes much more efficient use of the spectrum and much better services, particularly for people who don't need that kind of reliability at different price classes. PlusNet is a fantastic example. It's a British ISP that uses DPI to segregate traffic into 7 different classes. It wins awards for customer service and for overall service. It makes people who use the network in certain ways extremely happy because it's able to optimize it. Again, prioritizing based on applications and being able to deliver a product with great transparency, explaining to people how it works, but it's very effective. Comcast Digital Voice and AT&T's Uverse are kind of similar. Basically, they're compensating for limited bandwidth. AT&T's Uverse is a VDSL strategy, which is fiber to the node and gets greater leverage out of the existing copper wiring system so they don't have to lay fiber all the way to the home. The problem is they don't get as much bandwidth. It's cheaper. It's $7 billion versus $24 billion for Fios for roughly the same amount of households, about 18 to 20 million. The problem is they only get 30 meg of bandwidth, whereas Fios is offering 100 meg and they've tested up to 10 gig. So what do? The only way they can offer video is they do a lot of things like switch digital video. They don't broadcast all the channels, only broadcasting the channel you're actually viewing. But in addition, they use DiffServ to prioritize their offering. And it's available when you're not on the television for general internet, but they basically say that's the only way they can make it work in 30 minutes. Public safety spectrum is a great example. The D-block auction says sharing spectrum, it's like when the ambulance goes through, we all get out of the road, the way of the road, so we don't have to build a separate lane. It's basically the same thing. They say this reduces costs, it increases the efficiency of the use of the spectrum. It's the FCC's clear recognition that prioritization for higher value uses is a valuable option of way to reduce cost. And the way it reduces cost is 24 billion versus 7 billion. You're seeing in the network neutrality proceeding, the Minority Media Telecommunications Council has filed saying the inability to prioritize is going to raise the cost of networking and it's going to hurt the digital divide. And if you see the filings, all the rural members of Congress, mayors, they all came in actually going against it. And the last thing is Internet 2, which is a university-based consortium that is often pointed to as a person that says no prioritized service because of testimony they made in Congress. They actually tried to make a prioritized service work and decided that they couldn't do it. It's now got a new service called the Internet On-Demand Network, called ION, which is a virtual circuit network. It's a temporary setup where you can actually reserve resources, get 100% of that bandwidth in ways that to support the kind of applications that need that very badly. And so, if you want where the rubber hits the road, I've tried to sketch out a few examples of how this works. And I think that on a broader level, and this is reflected in a piece that I just released in a book I'm working on, is that there is a broader change in the internet, which is the number of users is much broader, the number of applications, technologies, and business relationships underlying it are become much more heterogeneous. And what we should expect is the entire network infrastructure to respond to those differences by trying to vary the services they provide to meet different parts of the network, because if everyone wanted the same thing, you'd have one network optimized in the same way. If what people want differs, you expect the network providers to vary what they offer and to start getting different services to serve different parts of the network. And I think that in many ways what we're seeing is a very natural evolution based on the way that the fundamentals of the network are changing.
Okay. Thank you, Rob. Appreciate the invitation here today. Or actually, at least I did until Richard showed that slide of a Model 33 teletype and paper tape punch. There are things in my history that I'm trying to forget. And I've spent many years with one of those sitting right next to me. Anyway, where's the thing? That little thing? It doesn't work.
What it does is it sends a signal to Catherine.
She looks very impressive.
Did you do that? Oh, okay. Yeah, but I don't know which way it's going. Well, this is just going to tell you the points I'm going to try to make. First point I'm going to talk about is an interesting thing. It parallels what Christopher just mentioned, which is there's an interesting phenomenon that in the wireless world, you can actually get extra capacity if you're willing to accept a mix of high and low priority traffic. Wireless systems, if you it may not be obvious, but you probably noticed that when you get in an elevator, sometimes you lose your signal. And there are enormous variations in the strength of the signal from a base station to a handset, from a handset to a base station. because it thinks it's blocked, it's multipath, and the strength of that path can vary by factors of 10 or factors of 100 in a fraction of a second. Consequently, one base station will be serving multiple subscribers with a single radio signal. And on average, it may need X units of power to serve all those users, but each user's needs vary, and sometimes every user's a little bit worse than average. And in that situation, there has to be some backup capacity, or they'll have to start dropping calls at that point. So these systems run with some reserve capacity that's only used 1% of the time, or that's enough to meet their needs all but 1% of the time. And most of the time that capacity is idle. If you can see this chart at the bottom, this is reports some tests that were done. I don't know if they're simulations of tests by some researchers at Qualcomm, and when they took a system and used 100% of the capacity for data, they got data capacity of 1 unit. If they then added voice users up here, they had 40 voice users and then used the leftover capacity for data, they're down to about 40% of data capacity. And so that says if you're going to provide 2 services on that radio link, voice, and basically at about 40 voice channels it's full, they quit working well after that, you can still get about half of the capacity for a data service. But if you had a rule that all bits had to be treated the same, then either you could fill the whole thing up with data, get 100% of the capacity for data, which means if anybody used that data link for voice over internet protocol, it'd be crummy. Or you could get roughly 60% of it for a high quality voice service and leave 40% idle. But there really isn't a middle ground. It's funny. I was using there was a company called Zoom involved with Sprint that had a service here in DC, and it was great. I think Clear now has a very similar service. It was great. You get 2 megabits per second wireless to your desktop, and I used Vonage over it. It worked, but it was really terrible. It's unacceptable quality. And I mentioned this to somebody else in the industry, and they said, "Oh yeah, well Vonage told me that Clearwire just designed, or Sprint just designed that system so VoIP wouldn't work on it." And I said, but wait a minute, these systems basically have a dial on them, and if there's a trade-off between latency and capacity, and if you turn the dial up more capacity, you get more latency and VoIP quits working. It's just the laws of physics. And if you are willing to tolerate priority, then you can mix high and low priority traffic on a high capacity link. But if you insist that all bits be treated the same, either they all get crummy latency or you give up on capacity. Let's see. Have I run out of time already?
No, not yet.
Oh, I can't see your time.
Send an update.
Oh, it's trying to do something weird, updating the software?
Yeah, it is.
All right. There's another similar feature, which I won't take the time to talk about now, called hybrid ARQ. And if the wireless link is smart enough to understand that and treat different kinds of applications differently, it can increase the throughput. I won't go into the details there. There's a lot of, just the last bullet on this slide, in the wireless world, there's a very large literature on what's called cross-layer design. Just like people have a religious attachment to the end protocol argument, it was just an insightful way to think about how to design things. There's a strong religious belief that the layers should be separated, they shouldn't talk to each other. But in fact, in the wireless world, it's been found that if the lower levels have knowledge of the upper levels, then they can behave more intelligently. They can say, "Gee, I'll treat this packet differently than that packet, and I'll deliver efficiency to the higher level application." Similarly, if the higher level applications the higher level layers can inform the lower levels about things like relative priority, those lower levels can perform more efficiently. And one of the reasons for this is that wireless systems just are much higher error rate than wired. If a typical bit error rate on a local area network in an office is, 1 bit in a billion, 1 bit in a trillion, then a wireless it's more like 1 bit in 100,000, on a good day 1 bit in a million. And consequently, you need quite different approaches to exploit the most out of the system. Here's also another observation about the best internet congestion control generally and best effort traffic, and that is congestion control in the internet works on the honor system. Quote from one of the RFCs, first quote there from a textbook. Second quote is kind of interesting. It was on some of the public correspondence among the Google Chrome web browser developers, and one of them is talking about there's an RFC that says you shouldn't have more than 2 of these certain kinds of connections. And Chrome had cranked it up to 6, which gives you a little bit better performance. I'm sorry, at the expense of being a little bit worse neighbor. But then Firefox jumped up to 15, and now this guy's lamenting, geez, I don't really want to be a really bad neighbor, but on the other hand, I don't want to have an inferior browser. What am I going to do? And if you think about it the other way, when you're thinking about how networks pass out capacity, if an application doesn't follow, or a user doesn't follow the honor system, should ISPs enforce it in some fashion? Should they give priority among users to give more priority to users that are playing by the rules? You just look at this very briefly. This is an example of where there was a very important bulk data transfer to many users, but that it basically crashed the ISP, and the ISP cut it back. But it was still sensible. Similarly, what do you do if there's a massive failure in a network, various kinds of failures? What do you want your ISP to do? And then here's a slide that Chris has seen before, and he already used it. Some time ago in one of their finds, the FCC Free Press said that priority routing is a zero-sum game. Speeding one packet slows another. Well, maybe if all packets do exactly the same thing, but if you think about road networks, it's certainly not true. We all, in sort of I don't know about, maybe I'm speaking for others, incorrectly to speak for others, but I'm never unhappy at the thought of pulling over to let an ambulance go by, because I know maybe tomorrow I'll be in that ambulance. And so, maybe I'll get it back. And the option, I value a lot the option of getting ambulances that can go quickly. I think most people feel that way. I don't necessarily. And so, some concluding thoughts. I sort of think, what would you want if you just stood back and thought about how you'd want your ISP to behave? I'm a Vonage user, so I'd like voice to be given preference over bulk data transfer, even though I do large downloads from time to time. And I think if you think about it, if you really forced all bits to be treated the same, inefficiencies in wireless networks, but you'd also select among the kinds of applications that would survive on the internet. I think in his introduction, Rob was making exactly this point, that if you want the internet to evolve to be a truly universal network, then you have to allow every kind of application to thrive on it. And there's a real incentive effect involved here. If you say that priority applications can't run on the internet, then people will build other networks that can do priority, and it'll turn out maybe there'll be MPLS networks to the premise. They'll also actually be able to do the internet, and someday they'll replace the internet, or we'll have billions and billions of dollars of waste and denied service if we go that flawed route. Thank you.
Okay, so by way of introduction, for those who don't know me, I'm a professor of computer science. I've been working on quality of service issues for about 20 years, including working at how pricing may help in quality of service. Got into the policy world a couple of years ago, so I've always been publishing on net neutrality and traffic management. and should say have not accepted money from people on either side of the debate. Okay, so a little bit of history. Chris actually did a good job of this, so I'll go through this pretty quickly. The original idea, as others have explained, the motivation was that certain kinds of applications need different kinds of performance than other kinds of applications. So things that are off to the right-hand side of this chart, your email, if it gets through within a minute or so, you're pretty happy. For web browsing, if your page downloads in a few seconds, you're pretty happy. But for teleconferencing, video conferencing over the internet, you want it to be there within a few tenths of a second. Otherwise, human nature is that quality doesn't sound very good. So the first idea that folks had in the research world and carried over to the internet standards was that some kind of prioritization or some kind of reservation scheme. Things that are toward the right-hand side, best effort's great. Things that are toward the left-hand side, you want them to have some kind of priority if you want the performance to be really good. Okay, so this is exactly the same as what Chris and other folks have said. So what does that mean? Well, first, we have standards for it, and I'll hint at this as we go through. But I want to set a goal. I think the debate is not so much in terms of should there be prioritization or not. I think this topic has matured in the last couple of years, and I think on both sides we're hearing much more acceptance of prioritization. So I want to set the following goal. I think the goal should be the QoS is not only available, but it's available widely to applications that need it. So here in blue blobs, there's a whole set of applications that if we want them to, in the future, to have really high performance version of these, to have good performance of these, they all need access to quality of service. And I think the goal should be that we want an internet to which these applications can mature and obtain quality of service. And what we don't want is that only managed services that are run by the ISPs have access to QoS. We want it widely available so it's competitive, so that innovation happens all over the place. Okay, so what does that require? First thing means you want to keep in mind QoS not available just to managed services, but widely available. Okay, so what do we want? I want it to be available widely, and I also want it to be available end-to-end. So let's suppose I am back at my home university in the lower left. I'm trying to set up a video conference room at the FCC up in the upper left. We are not directly connected. We go through a bunch of ISPs. So here I'm making up the scenario, going through AT&T, going through Verizon, going through other folks. I want to be able to have that QoS all the way from the beginning to the end. What I don't want is today's situation where maybe the FCC can have a contract with AT&T for managed service, but I can only get QoS if I'm on AT&T's network. I want to be able to get it even though I'm at my university and we're not on AT&T's network. Okay, so a couple of possibilities. How would you do this? Well, the first thought was QoS should relate to the application. So the first naive approach, where we started in the research world a couple of decades ago, was let's tie the QoS directly to the application. So here's how that would work in today's internet. Packet gets sent out from the FCC, it hits AT&T's network. AT&T has to look inside the packet and say, what kind of application is this? So that's what we call deep packet inspection. They may say, aha, this is a voice over IP packet. It needs priority. We're going to give it priority. Goes through AT&T's network. Hits Verizon's network. Verizon has to do the same thing. Has to look inside the packet, say, aha, this is a voice packet. I'm going to give it priority. So the problem with this, researchers recognized 20 years ago, was that this requires each ISP to be looking inside the packet, and it also requires that we make a very exhaustive list of which applications need which quality of service. And that's unmanageable because innovation means that applications evolve very quickly. So we said, no, this is not the way we want to do it. We want to decouple the application and the priority in a way that you'll see coming up. So here's the next possible thing, and this is where the debate's now moved to, is can I have the customer purchase the quality of service from every ISP on their route? So in this example, FCC would have a contract with AT&T. They would, let me take the other way in the slides. UCI, let's say I'm paying for it. I have to have a contract with AT&T to buy QoS. I have to have a contract with Verizon to buy QoS. Similarly for every other cloud along the path. So this works, doesn't violate the standards, it's not what they have in mind, but the problem is that it requires me to have contracts with every possible ISP wherever my traffic's going to go, and that's unmanageable. So the folks that created DiffServ is one of those standards that's been talked about, said, this is not what we really have in mind. What we have in mind is it should be widely available, it should be easier to do. So here's what easier to do is. Here's what the standard had in mind. The customer or the application says, I need QoS, I need some kind of priority. That packet goes through the network, it hits their service provider. When it hits their service provider, then let's suppose their service provider is AT&T. AT&T looks at the header of the packet, sees that priority has been requested. The question is, what motivation does AT&T have to honor that priority? And the premise here is that the customer and AT&T have a contract. If the customer is part of that contract, has purchased some QoS, and AT&T says, aha, they're entitled to it, we will let that packet go through our network with priority. Then it hits Verizon's network. Now, on the previous slide, I would have had to also have a contract directly with Verizon. What was envisioned in DiffServ is that AT&T and Verizon have a contract with each other. They have a contract with each other today, called a service level agreement. What we want is we want them to evolve into the future so that they also talk to each other about QoS. So, for instance, AT&T will say, I'll give QoS to Verizon's packets if Verizon gives it to my packets, or we'll honor each other's code points. We're not there today. I think that's where we want to be in order to be able to move QoS available so that it's widely available. So I think this is the goal, and this is essentially what the standard lays out. And the standard does not get into the non-techie pieces. Right? These are people who don't know this policy world. They said economics is not our domain, the policy is not our domain, but this is the vision that they had in mind. And I think it's consistent with where we'd like to see this thing go. Okay, so let me bring it back to managed services. So the question is, what are managed services? And we've been seeing all kinds of attempts by both sides in this debate to define managed services. And they've failed fairly miserably so far. So here's a few hints at it. So my take on it, managed services are applications that require QoS. So all of these things are sitting on top of QoS to make them work. The problem that they've been having is that they've been trying to write language to say managed services is blah, or managed services is not the public internet, and the public internet is blah. And everybody's been failing at it. Here's a new idea for folks to fool around with and see how it works. I think that you can get away without having to define managed services if you take a different definition of net neutrality. So yes, one more yet. Here's one way to approach it. It's a notion of fairness. So what I want to do is I want to say if an ISP uses QoS for its own applications, so for instance, AT&T uses it for UVerse, Comcast uses it for voice over IP, any of these kinds of things. These are great. These are good things. It helps. But I want it to be available more widely than that. So I think the rule, and yes, I mean the rule, should be the QoS is available on reasonable terms or insert your favorite lingual language. It should be available to subscribers, to the residential subscribers, so that they can use it for any application they want. It should be available to the business subscribers, so the internet companies that are also in this debate, so that they can deploy it and compete. And they should be available to other ISPs. It should be worked into the peering and transit agreements, so that it's not just within a small cloud, but it's available end-to-end in the internet. So what you'll notice is, take that upper part of the slide. I didn't have to use the word managed services. I don't have to define managed services. I get away without doing it. So this is my challenge to policymakers, is see if you can come up with a rule that counters this notion of widely available QoS, brings in this notion of a level playing field, but doesn't require you to do managed services. And I think it's doable, because I think this hints at how to do it. And more details available to those who want to see later.
Thank you. I actually don't have any slides, and it's a good thing because the slides I was thinking about bringing would have been quite similar to just points that have already been made here today. It's hard to go fifth on a panel with such great participants. I'd like to talk about two things today. The first is sort of give a couple of examples of how AT&T uses this thing that we're talking about here today, differentiation, DiffServ, MPLS, how we use these things in the network. And then the second is to sort of give my perspective on where this is in the policy debate, this issue, where it sits today. Chris Yu actually took my first example, which is Uverse. And so, as he said, we use diffserv and also some other tools, like Ethernet tools, like VLANs and things like that, in our Uverse offering. And as he described, Uverse is a service that takes basically a 25 to 30 megabit pipe VDSL connection and combines multiple services on it: voice over IP, internet access, and multi-channel video service. So in the Uverse service, in the network, there are a number of queues, and a queue is just, in an event of congestion, traffic is sort of segregated into different queues, and the different queues get different treatment depending on what's specified for each queue. So the highest priority queue in Uverse goes to real-time applications. Voice over IP and femtocell would be the main examples. The second highest priority queue actually goes to network management things that the network needs to do. As you go down further, then you'll hit the video service, which is an IPTV service. It's a switched video service, as Professor Yu described. And then finally, at the bottom, you run into the public internet service. This capability was critical to the, to being able to offer Uverse, being able to do this. If you think about it, there are a lot of video services on the internet, and increasingly more, that work very well without any QoS. Basically, services where you can buffer, if the use case is one where you can buffer the service, and there's enough capacity that you don't have to worry about having to rebuffer during the time when the viewer's watching it, there's really not a real need for QoS on a service like that. But for a service like Uverse Video, multi-channel video service, where the end user has to be able to push the button to change channels and instantly tune that other channel with no packet loss, no latency, anything that disturbs the quality of that experience, we couldn't do that without having this capability. So that's one example. The other example I'll talk about briefly is the use we make in circumstances on our backbone where we have customers who have SLAs, service level agreements. So the other thing I'll say is I don't have a presentation, but these slides were actually used by one of our executives last year in a workshop that Professor Jordan did at the FCC on network management last December. And that's still available at openinternet.gov. So that was actually, I thought, a great event, and I would encourage people, if they're interested, to go and look at those presentations. There were a number of really good presentations that day. With respect to these backbone services, we have at the top of the stack a very small amount of traffic which is reserved for government emergency telecommunications services. This really gets a form of treatment that you can only do for a very small amount of the total traffic on your network. It's a kind of handling that's called express forwarding. Basically, it goes to the front of every queue at every router. So you can't do that for much traffic, and we only do it for the government emergency telecommunications traffic. Then below that, you have real-time applications, once again, voice over IP and other real-time communications that are handled in the next queue. Below that, you have services that we describe as private data. Basically, these are enterprise VPN services. And then at the bottom, you have public data services. So this is peered traffic, ordinary consumer or business internet traffic. And so, again, these things work together, we think, to enable us, and this is, by the way, using MPLS in the backbone. They work together, we think, to enable us to provide excellent services to meet the customer's expectations for the performance of different applications. And without these tools, I don't see how we could actually provide these services on one common network. Now let's talk a little about where the policy debate is, because I think that many people have, or a number of people have suggested today that the policy debate has narrowed, and I think that's exactly right. I think that the zone of disagreement about prioritization and about this kind of differentiated services is much narrower than it was 18 months ago, 24 months ago, at any point in time. I think Richard kind of captured it. There's sort of angels versus devils. There's a concern that there might be certain kinds of practices that evolve where basically ISPs would be, in effect, exploiting a terminating monopoly to force otherwise unwilling customers, people who wouldn't even want to be their customers, to pay them to get adequate handling on their network. That's kind of the devil vision. And then there's kind of the angel vision, which I think is closer to what Scott Jordan was talking about, which is, let's get to a world where QoS is available to the applications that need it, and it's available on an end-to-end basis. I think that is really, the goals that Scott laid out are really the right goals. That's the way we should be thinking about this. How do we go from today where differentiation is, for the most part, fairly balkanized? It's available on individual networks, on portions of individual networks, and it's available for a relatively small number of applications, to a world where it's available on an end-to-end basis. There's a lot of barriers to getting from here to there. I mean, there are transaction cost issues. There are chicken and egg problems. There are a lot of things we have to overcome to get there. But if we think of that as the goal, that puts an entirely different sort of view on the whole net neutrality debate, because you're no longer focused on we have to prohibit X. We're actually trying to get to somewhere positive. We're trying to get to this world where QoS is available to the applications that need it on an end-to-end basis. So I think, I would wholeheartedly endorse that goal. And I think if we were to take that goal into the question that Richard raised earlier of how do you write a non-discrimination standard, I think having that goal in mind leads to a very different answer to your question of how do you write a non-discrimination standard. And with that, I'll end my remarks with 1 minute and 26 seconds to go.
Hi, good morning, everybody. I want to thank ITIF for having me here today. As part of the hoi polloi, I've been asked to try and translate some of this for the lay people and summarize the current political environment. So, tough job, right? To me, my understanding of differentiated service is that not all internet content is created equally and therefore cannot be managed equally. And I would tend to agree with Scott that that there is, agreement that there needs to be some level of prioritization. And why does this matter? Because it's at the very heart of the debate over net neutrality and the effort to get legislation on this issue done. People or the fiercest advocates of net neutrality think of paid prioritization as the devil that will lead to an internet where consumers and small businesses are losers and corporations are winners, whereas as we heard from the engineers and industry, they say, hey, this is absolutely essential to doing what we want the internet to do for us. What hasn't been brought up yet is, there are some areas of prioritization that I think are, there's obvious consensus. Yes, people would want, AT&T to prioritize calls to 911, and yes, let's advance in telemedicine. But the area where there's, I think, more debate is in general commerce. To what extent should these carriers be allowed to charge fees for managed services or a different network that's not accessible to the public? And I think that's where the debate needs to be sort of fleshed out more for the public, where the case needs to be made more for why that will be okay, and consumers at the end of the day won't lose out. What people will say is that if there is this sort of secondary non-public internet where big businesses are allowed to pay for faster treatment of their content, the investment will go into that non-public internet, and then your average consumer or smaller businesses will be left with an inferior internet. And all this is hypothetical, but that's sort of where the argument stands. So I'll get to kind of what's going on with the current political environment with all this. As I'm sure everybody in this room knows, efforts to move forward with a House net neutrality bill collapsed this week. Henry Waxman, who leads the relevant committee in the House that has jurisdiction over this issue, failed to get support from the Republicans on this matter, and called it off before he was able to even introduce it. Going forward, I think it'll be a period of inaction on what will happen on regulation over the internet for some reasons of process I'll point out in a minute. But in the meantime, I think there, as I laid out in an article that went up this morning, are going to be sort of spin wars of people on the various sides of the issue trying to position the debate in terms favorable to them. Much having to do with what Chairman Waxman said in his statement, conceding that he couldn't move forward with this bill at this time because he couldn't get Republican support. He said two key things. He said that he was going to work on this again in the lame duck session, and he also called on the FCC to reclassify broadband under Title II of the Communications Act if Congress fails to act. And Title II is a more stringent regulatory regime that many members of Congress oppose, and most of industry opposes, although it's not as simple as the sort of industry business right and left issue. There are some industry that supports that, such as the Communications Computer Industry Association and Dish Network. So people on the side of the issue who would like to see or avoid reclassification at all costs are going to come out and say, like AT&T, refrain thing here, that this Waxman's efforts clearly show that a legislative solution is possible, and we need to move forward with this path. And then people on the other side of the issue, the public interest groups, are going to say, no, what Waxman said was a clear mandate that the FCC has to move forward with reclassification. So I think you'll see that jockeying in the near term. The reason that there isn't going to be any action probably until after the elections is for reasons of process. The FCC has not put that item on their agenda for their monthly October meeting, which will be October 14th. And they need to circulate an agenda about what they're going to discuss 3 weeks in advance of their meeting, and their next meeting isn't happening until November 30th. So it would have to be a real about face for them to throw that on there, which is sort of the biggest issue that they could be dealing with. And I'll also offer some reasons why I think it's virtually impossible that this bill will move through the either chamber of Congress during the lame duck session. First of all, Senator Rockefeller, who chairs the relevant committee on the Senate side that would deal with this issue, has said as recent as this week that he still favors reclassification of broadband under Title II, and that was something that the draft of the Waxman bill took off of the table. So he's against that. When I asked Senator Kerry, who chairs the relevant subcommittee, if he'd be willing to shepherd a net neutrality bill during the lame duck session, he said, "Oh wow." Completely shocked by the question and sort of trailed off, which goes to my point that telecom issues are fairly low in the totem pole for a very packed agenda in the lame duck session. They're much more worried about tax cuts and other bigger party agenda items. Senator Dorgan, who is a really fierce net neutrality advocate, has already come out public against it, and he's retired. He's got nothing to lose. So, and as we know in the Senate, one senator can hold up the whole process. So, I mean, never say never, but it's hard for me to see how there's any possibility of that happening there. So, what does that mean for after the elections? I'll just offer a few thoughts about where this issue is going to go. I think it'll be more difficult to get legislation that prevents managed services or blocks them in any kind of broad way after the election, because there's going to be a more hostile environment for the fiercer advocates of net neutrality. Everybody who is lined up to take control of the relevant committees on this issue, if the Republicans take either the House or the Senate, are strongly against this. In the House you have either Fred Upton or Cliff Stearns, who now that happened, and in the Senate you have Kay Bailey Hutchinson, which is likely to take control of the relevant committee of the Senate. So I think that's sort of where things stand there. If there is going to be any action in during the lame duck session on this issue, I think it would only be because the FCC surprised everybody and decided to go ahead with reclassification, in which case the Republicans would have an incentive to do something about it then, because they would not, on the whole, want that. So with 52 seconds, I'll stop my comment there and move back to Rob.
That's great, thank you. We're going to hold you to that, by the way. In that room. Well, I want to apologize for everybody because I really was disappointed that none of the panelists engaged in flame-throwing religious, ideological, black and white Manichaeism. But we'll do the best we can. We invited all our
That's how I described the Model 33 teletype.
Well, that's all right. I'll give you some credit, Jeff.
Some of us use those.
Before I open it up for questions in the audience, I want to ask maybe everybody who wants to weigh in on this. first of all, I thought that was really very enlightening, and to me, one of the things that it illustrated again is really how, and the internet, if it's anything, is an evolutionary system that we keep learning more, the technology changes, as is IT overall, and that the notion that somehow we can come up with a sort of one-size-fits-all kind of 10 commandments that we will live with for 100 years is, to me, a ludicrous idea, when one that unfortunately seems to be the one that a lot of people think of. Having said that, there are obviously concerns, and some of those were raised here, particularly market power concerns. How would people respond to the pricing power concern? There's the inability for new entrants to come in the market that some people raise. I mean, in this model, and maybe you could also, if everybody agrees with Scott's vision as well, it seems to be a pretty compelling vision. I'm personally involved in this now because my son's now living up in Rhode Island, and we Skype every weekend. And some weekends it's pretty nice, and other weekends it's abysmal, and we hang up, cut the thing, and we just pick up the phone. I would like it to work well every weekend, and it doesn't. I don't know why. Richard can tell me that, I guess. But so anybody want to sort of jump into that? First.
First, I love your example of picking up the phone. It's a perfect example of a managed specialized service. I mean, to be honest, the idea, and when we think about how young people are they're not using email, they're using SMS, which does not travel through the IP stack. It's a separate service, it's a telephone-based service. It's a very different world. The idea that we'll see it all on one homogeneous network is a vision that we're not seeing today. In answer to your specific question, I would say that this is where we have to go back to the old competition policy days. We have a world where we deal with market power. Antitrust laws deal with this. And they've got a problem there, which is we're skipping a lot of steps in the analysis because antitrust claims have been easily made, especially collusion claims, conspiracy claims, and it can churn up an enormous amount of litigation resources. So we now created a set of filters to actually knock out bad claims. So first, does the player have the capability to actually harm competition? There's a structural analysis, certain structural preconditions that have to exist before you can go forward. Second, is it profitable? Do they have the ability, incentive? And in fact, they make people assert a theory to survive summary judgment, to actually explain not some generalized notion, but a very specific notion about how it's going to harm competition. Third, even if they have the incentive, there's a welfare analysis. Is it actually going to hurt consumers? Because a lot of these steps don't. And then the fourth is, can it be remedied in an effective way, or would the cure be worse than the disease? And once you have a structure like that, you end up with one that we've learned the hard way through a century of antitrust policy about how to cabin this in a way that we can get the claims that do need to get remediated, because I've always favored case-by-case work, even though people call me a deregulationist on one panel that Scott presented, then the next person called me a regulationist because of what I'm about to say, is I think an ex post case-by-case world makes a lot of sense because you cannot rule out the possibility that anti-competitive harms can occur. What makes sense, though, is to cabin it through the lessons we learned through antitrust law in ways to knock out the non-meritorious claims very quickly. One comment about Scott's proposal, I love the idea that we're talking about optimality now, because that's how engineers think, that's how economists think. These corner solutions of absolutist, it must be X, it must be Y, is not helpful to the debate. That's not how anyone who's seriously thinking about this is. His proposal, though, I will throw one on the table. It reminds me of those of us who know the telecom history of CEI, comparatively efficient interconnection from Computer 3. Because basically saying is that if you use the service, you've got to apply it, offer it on an unbundled basis to everybody else. And the answer is CEI was a mixed bag. And the answer, there was arguing about how far you have to disaggregate it, what was truly efficient. And in a world where we have the biggest problem we've also learned from non-discrimination and antitrust is when you have services that are non-standardized and vary in quality, non-discrimination agreements are very hard to enforce because it's hard to figure out what's non-discriminatory. The second problem is when you have production technologies like cable and wireless and fiber and DSL that are radically different in cost. Everyone accepts that if it costs differently, you can charge differently, and it's very, very hard to unpack what's non-discriminatory when the underlying technology is.
Sure. So I'll respond to two things. One is, let me just make the worry concrete. So using the Skype example, let's suppose that at some point Skype decides they want a higher performance version, and they go to AT&T and they say, we're an AT&T subscriber already, we'd like to pay AT&T in order to get QoS for our voice service. I don't know today whether AT&T will do the calculation and come up with the answer that they'll sell it because they can make more money by selling it. It's a new income stream. Or if they'll do the calculation and come up with the answer that they can make more money by not selling it and being able to say our voice service is better than Skype's. And they should do the calculation and they should do what's best for them. But I don't know which way it comes out. And yet public interest may say we want the competitions, we want it to be former answer, not the latter answer. Coming back to the last slide I had with the pitch for fairness. So the one thing I'll say about that is details not presented there. But you can do it in a way that's not unbundling. You can do it in a way that requires only a single open interface, and that open interface already mirrors current architecture. Whereas unbundling said they have to allow access in all kinds of different ways, and so this is much simpler than unbundling otherwise.
And this is recreating the fight in computer theory between CEI and ONA, right? ONA was full unbundling where you had the building problems. What the lurking problem with mandating an open interface, though, is it locks it into place. Is that if you say that you have to provide this, you have to allow, it basically means that anyone who shows up at this point with their data configured in a certain way has to be given carriage. Now, the attractive thing about Scott's proposal is you only have to do that as long as you're doing it yourself, which is the CEI notion. A lot of the proposals on the table would actually say, it's not pegged to what you're doing for your own services. They say, you must architect an interface here in this way that carries traffic of anyone who shows up. And the problem is we've discovered is interfaces move, they collapse. Things that were interfaces once, they're no longer interfaces. The protocols, the way they communicate across interfaces change, the information that has to get passed over that. And by locking that into place, it's an oddly conservative move, which is we want the internet as it exists today to last forever. And the problem is we have a technology and a demand and a consumer user base that are demanding their internet.
Hey, do you want to respond?
Sure, I actually would like to. Scott asks a great question. What would AT&T do? The fact is, at least on the for the small, medium, and large business side of the market, we've already decided that. If you're a business customer of ours, you can buy in addition to your internet access service, you can buy for an additional charge the ability to yourself determine which packets that you send should receive higher quality treatment. And if you mark packets as real time, we will give them real time treatment across our backbone. And if we had agreements in place that Scott alluded to earlier with other backbones to sort of have interdomain quality of service, presumably they would honor that too. So I think to the extent the users of the network are sophisticated enough to do that kind of thing and they're willing to pay for that capability, we've already shown we will offer that capability to the market. And it sounds like you wanted to say something, Chris.
I wanted to follow up on that. First, I'm not sure Skype is a perfect example because it's a sort of distributed enterprise. But if you think about an enterprise like Vonage that really sells a service, then much of what you said would be the same. But Vonage is a big guy, and if they don't like the deal they get from AT&T, they go across the street to level 3. Or to Verizon. Level 3 doesn't, you don't have to worry about level 3 having cannibalizing their phone service. And so if AT&T doesn't sell it to them, level 3 will. And level 3's got a real good national network. And there are other choices out there as well. So if you're thinking about the options for big guys like Verizon, you have to say this is a really, really competitive market. There are a few locations in the United States where people only have a choice of DSL or only cable modem service. Turns out, and they can't see a satellite, and wireless doesn't work there. But all big enterprises and most end consumers have a choice of a couple suppliers at least.
This is a really interesting question because I think it kind of shows how the net neutrality debate has created confusion about this technology. Okay, so the rationale for differentiation in the network is application diversity, right? I mean, we need low latency for certain applications like voice over IP. But so it's a difficult engineering and economic problem to sort of take something which isn't a norm on the public internet today and make it into a norm. And so that's kind of the technical tension. That's what engineering wants to do, is make differentiation available on the public internet in order to allow heterogeneous applications to develop. But when that problem gets translated into public policy and sort of the hoi polloi of net neutrality, it changes, right? So the way the net neutrality advocates hear this issue is not that you want to make Skype work better, it's that you want to make somebody's website load faster than somebody else's website. So you have to have deep pockets to pay for this service, which is something to do with making somebody's content more available than other people's content. And it's not, I mean, that's not really the point, right? And to me, it's like every time somebody criticizes differentiation because of some website reference, it indicates they don't understand the issue. Because we actually have means on the internet today to accelerate websites, right? It's content delivery networks like Akamai. And yes, in fact, people that have deep pockets pay for that, but people that have deep pockets and pervasive websites also have a lot of eyeballs. And so they have the need for that kind of acceleration. So that exists whether ISPs are prioritizing packets or not, simply because geographic prioritization. And most of the network neutrality advocates think that's okay. And so I think what we have to do actually to get the dialogue on track is to sort of make it very clear that we're not talking about means by which, you know, AT&T or Verizon can make one website load faster than another. That's really under the control of the website owner today already. But we're talking about means for enabling new applications.
Let me, thank you. Let me turn it over to folks in the audience. If you want to ask a question, I want to let you hold on for the mic and just identify yourself, please.
Okay, Rob. Sorry, I'm Dean Darfield, and I'm the president of ITIC, which is related to ITIF. Two questions, mainly technological, one picking up on the point that Richard just made. The first is Scott's vision of, I guess, consumer-driven, non-discriminatory prioritization. How far away are we from that technologically? Is that technologically feasible in the near term? And then second, the argument that Richard just alluded to about prioritization crowding out best efforts internet. Part of the retort to what you said, Richard, is that in fact CDNs are pretty inexpensive, and so anyone, even the guy in the garage, can access them. How do you respond to that?
Scott, you want to go first?
Sure. Technical structure is there. It does require some significant work with ASPs, and it's not trivial for their engineers to do it, but they're already doing network dimensioning and the traffic management to do their managed services. It just requires a little bit further out foresight of saying we want this available not just to those applications, but to more widely and available to end-to-end. So I think technically it's doable. The piece that's an impediment is we need the economic and legal arrangements to be put in place to make it happen. On the CDNs, let me partially agree with what's been said. The debate should not be about how fast websites load. Right? It should be about applications that need quality of service. Those are traditionally things that are more interactive, more real time. I think the debate is moving that direction. So this is good. One other thing. I'll come back.
Rob, can I jump in just on one point? The barriers, how do we get to what Scott's describing? I mean, the technical barriers aren't that great at all. I mean, the real barrier, one of the biggest barriers is this whole debate about net neutrality. Every time another backbone comes to AT&T and says, do you want to enable interdomain QoS? The question gets forwarded to the regulatory people and the legal people rather than the engineers. I mean, if we could get the net neutrality debate in a position where everybody knows it's okay for networks to talk about interdomain QoS, that would probably be the thing we could do the most that would, act to remove the barriers.
Yeah, all the routers have code in them, and logic in them to support diff-serve. I mean, and they've had it for years. I mean, Cisco made this presentation to the FCC that they couldn't sell a router that didn't have the capability to do this. And Juniper and Huawei and Nortel are all in the same boat.
So one other hint on the
Sorry, Scott.
on the one way to narrow the scope of the debate that I think is pretty easy is really what the pronoun neutrality side is concerned with is prioritization or discrimination mechanisms, and for those who know, network layering in the lower layers. So layers 1 through 3, for those who know what this is. They're not really concerned about things like caching or content distribution networks, which are up in layers 4 through 7. So one way to make the anti-net neutrality folks and carriers much happier and to not really lose anything from the pro side is to narrow the non-discrimination rules to just the lower layers. That gives them a lot more latitude to do things. The content are competitive, and you don't lose anything.
Yeah, but on the CDN question, it's there's two things that need to be pointed out about that. Number one, the CDNs don't work for all applications. Right? A CDN will accelerate content. If you have an application that wants to deliver a web page, by putting a copy of that web page close to the consumer, you accelerate the delivery of it. I can't do that with a video conference because that content doesn't get created until the very moment in which it's consumed. So that's a technical solution that sort of leaves the highly interactive applications off the table. And it also, CDNs also have another side effect, which is that they actually increase the load at the boundary to the residential serving ISPs. So by putting that content right at the edge of the ISP networks, the first mile ISP networks, they actually exacerbate the problem of delivering real-time content that originated somewhere far away. And so there's a real difference. And yeah, it's true that CDNs aren't that expensive, and more people, people that have needs for distributing content to a lot of people, or for doing video streaming or whatever, they find they're affordable. We don't know how affordable it would be if we had differentiated services end-to-end available across the internet as a whole, because people are afraid to offer that as a service, that it'll be illegal. So it may be affordable too. I think it probably would be. And we probably find that it has a much more limited utility than people fear.
That's the point, Chris.
Well, just really quickly, we've known since the 90s that the technical capability is there. The problem has been the economics. And the problem is this is where Scott made the point, engineers are afraid of economics. When you ever talk about business in the ITIF, they say, we're not going to go there. And the problem is what David Clark has said, we've never learned how to route money. The way an economist would analyze this is the average internet connection goes through 17 hops. You have 17 people fighting over, there's a surplus generated by it, and it's a common pool problem, they're all fighting over who's going to get what. And they have a set incentive to basically play chicken with each other, but it causes them to get more of it, and it causes them to lose deals. Economists have a very simple solution to this. It's called mechanism design. You need a market maker sitting across the top of it to make it all work. But that means someone is going to be sitting there, potentially competitive someone's, but bringing together all these resources. And then some people in the network neutrality space say, whoa, wait a minute, we don't want one big brother sitting across the whole thing. Now what we may see as the ideal solution is multiple big brothers competing with each other making these markets, but there's going to be a potential solution. And frankly, we've been hung up on this even before the network neutrality debate started flying up in the mid-2000s, and this has been a consistent problem that we've had all along. But I think Richard's, the bypass, the other point is, we know this, people in old telecom space know that something very clear. Bypass is always an option. And storage can be a substitute for networking. That's what the CDNs are all about. And that, in fact, as long as that's a real possibility, whatever we do in this part of the balloon by squeezing it, it's going to bulge out someplace else.
Dennis?
Actually, the panel's been circling around my questions, so they've narrowed it down to some extent in the last 5 minutes. I mean, I think an observation is that this debate's been going on across this for maybe 9 years or so, and just as sort of the parade of horribles on one side of the debate hasn't actually materialized, so too the potential benefits that people have cited on the other side of the debate in terms of dual west differentiation haven't materialized either. In other words, the market hasn't succeeded in producing the kind of organization and the kind of benefits arrangements that Scott talked about. So, Hank, you touched on part of this, which is sort of regulatory overhang. Okay, so set that aside for a moment. It's hard to improve the past. We've had this sort of parallel markets develop. We have old markets that are highly centralized, calling party days, and sort of rules that try to pass economic signals through and organize them in a certain way. And we know that they perform horribly, despite the efforts that we've made. In the meantime, we've had this sort of bilateral contracting market on the internet that's performed really well within sort of a narrow range of functions. So the question is basically, can that non-regulated bilateral contracting market that operates interconnection on the internet successfully implement the kind of thing that Scott's talking about on an end-to-end basis, or has it shown itself to be incapable of the necessary coordination to do that?
I mean, I think this is a question that you can only answer contingently. It hasn't happened yet. Christopher raises really good points. There is a serious coordination problem. There is a serious sort of chicken and egg problem. Until there's a money to be made, until somebody could demonstrate, if we did this, here's the money that we'll make, then the incentive to make these arrangements is not sufficient. There are some factors, though, that I think are going to tend to move it in the right direction. And I guess I would say the biggest one of them, from AT&T's perspective, may be 4G, and what that the wireless carriers are going to at some point move to exchanging 4G traffic with voice as part of that data stream, and that will require some sort of QoS mechanism interdomain. So I think there's hope that bilateral actions could work, but I certainly think it would be great to see competition among market makers coming out and saying, to people who are interested in buying these services, I can deliver this group of ISPs with an economic model that works for you. So I think we have to be open to both possibilities.
Yeah, another application that is emerging that benefits from quality of service and actually is a commercially real, although not a huge market right now, is the immersive video conferencing, like with the Cisco telepresence, and HP has an equivalent of that. There's a great service available on the internet called GigaOM Pro on the GigaOM blog, where you pay a little subscription, you get to read some reports that actually go into things in detail. And right, yeah, one of the writers is here. They did a report on video conferencing that sort of touched on some of these network arrangements, because that's the single application that actually stresses the internet the most. And it's not practical to do it on the public internet at all. So the companies that do immersive, we're talking about, this is not like Skype video conferencing with a tiny little picture. This is, where you're in a room with multiple HD monitors, and it actually creates the illusion that you're in the same room with the people that you're video conferencing with. I mean, it's amazing if you've never experienced it. You can't do it on the internet because the internet just is too statistical to deliver the quality that this application requires. So even Cisco, who knows a thing or two about using the internet, created their own private network to interconnect all the Cisco campuses so that they can do telepresence, and they rely on it quite heavily. And so what happens if you want to do telepresence with another company? Well, you either have to have a private wire to the other company, or there are exchanges emerging, private services like Telex did with email in the early days, where you get a private wire to an exchange, and then everybody else goes into the same exchange, and then you can telepresence to everybody that uses that exchange, and some of the exchanges are now making agreements between each other to aggregate. So we're sort of creating this whole alternate network for telepresence. And the traffic is enormous. I mean, half the traffic on Cisco's network right now is telepresence, and the other half is public internet. And that's an example. What we'd like to do is to enrich the public internet enough so that application can run on the public internet. And the benefit to consumers is that when people are not using telepresence, then the bandwidth and the circuitry that's there to support telepresence can be used by the regular internet, makes everything else run faster.
has been a very, David Leduc with the Software Information Industry Association. This has been a very useful session. I appreciate hearing from all the experts on the panel. I thought Elise's prediction was very conservative. The notion that Congress couldn't do this in the lame duck, I mean, frankly, they can't do anything in the lame duck. So, I mean, I think that was extremely conservative. I question whether or not they'd be able to do this in the next Congress, a few years, not 2 weeks. So my question to you experts is that you've done an excellent job of outlining the details of the debate, but does anyone on the panel think that the U.S. Congress can help this? You know, does anyone think that this is something that can be legislated? You know, this is obviously very high-level stuff, and we've talked about economics, we've talked about the technical details, but does it seem likely to any of you that there's a framework that can be put out legislative in this area?
I'd be glad to respond to that. I used to work for the House Commerce Committee and the Staff and Telecommunications Subcommittee, working on communications legislation, and we actually got it built with full committee members, but for a variety of reasons, it's very hard to move communications legislation. Constituents don't care much about it, and consequently, it's all Washington interest group politics, and there are many conflicting interests, and there's not much urgency. And constantly, you know, it isn't like the national parks are going to close next week if you don't move telecommunications legislation. So it's extremely hard to move telecommunications legislation.
I have one scenario for you, which is I think that there's actually a lot of agreement here. If you look at the Verizon-Google agreement, we were originally fighting over Michael Powell's 4 principles. Conceded. To October last year, proposed non-discrimination and transparency. Verizon-Google conceded. Put the burden of proof in favor of against discrimination, in favor of non-discrimination. That agreement conceded. And if you actually look at the IETF, the fact that the Waxman bill said we'll allow IETF or other publicly set standards to be part of the permissible world, which brings in DISCERB and all these other things we're talking about, and was torpedoed by the Republicans, I suspect, because they don't want them to accomplish anything before the election. I think that there's room. The question is, as Chuck points out, is there motivation? I can see one scenario where there's motivation. If it's not Title II, and if they can't find a basis for Title I, we learned from the computer inquiries that states can regulate. Because if it's not Title II, it's not exclusively federal, and if it's not preempted exclusively under Title I, the states will come. And they tried. And they fought this in California versus FCC and all these things. And the one thing that would motivate Congress is if they're going to lose jurisdiction over the whole thing. Then they might pass something, then the motivation to pass something goes through, and that's all you need to get, because there's enough consensus on it.
So we're all going to be debating the new Missouri law.
Or the Interstate Commerce Commission law of the 21st century.
Scott, did you want to?
Sure. Just 2 quick things. Policy, politics. On policy, I think there is potential to come up with the right answer. You know, I hinted a little bit at it. I think they have to avoid the pitfall of managed services. They got to figure out why is wireless different and not different. I had a technical talk on that on Sunday. I'll skip that here. Politics, politics not my thing. I'll certainly see that over. Except to just make one statement I got to make. This should never have been as ideological as we have.
And the good news is it's less ideological than ever. Is 74 Democratic reps wrote to the FCC weighing in against Title II reclassification. So what we're starting to see, it actually is coming up more rural-urban. And if you look at the dockets as they're coming in, is that in fact is the economics are quite different.
We will probably adjourn in about 10 minutes, so we'll ask a few questions.
Paul Sweeting with Concurrent Media Strategies, also Giggle to the plug. Following up on the previous question, and maybe Eliza is the best person to direct it to, what happens if this ends up in the courts? I mean, it seems to me that a plausible scenario is that given the difficulty of passing telecommunications regulation, that the FCC is eventually, even Janikowski's going to have to make a decision, and the FCC is going to act, and then it's going to be challenged, and then we're going to end up in court, which is where this quite possibly could get sorted out. And what is that? What would that do to the optimal outcome possibility?
I'll just take a brief stab at this because I haven't thought or read about it extensively yet. But I think if they do, if the FCC does go ahead with reclassification, that industry will definitively, take this forward. They will fight tooth and nail to have it overturned. So I think it sort of depends on how well the FCC defends itself. I have heard others say previously that in the Comcast court case, which threw their authority into doubt over this issue and sparked this whole idea of Title II, that that could have been avoided if the FCC had done a better job sort of defending why it had acted the way it did, and that part of it was because of sort of a lapse in information in the transition from Kevin Martin to Julia Janikowski. So I think that's the best insight I can offer there on where that would stand, and perhaps maybe how much the White House is willing to go to bat for this issue. So far, they have been reluctant to come out strongly one way or the other. Yesterday, they commented to me sort of that they thought Waxman's effort showed that compromise in this issue is possible. Perhaps they've yet to say anything about that issue, so I think they could influence how that goes. If anybody else has more thoughts to offer.
I think court litigation is always it's like going to a casino in some way. I mean, and the answer to any hard legal question is it depends. And anyone who says they know how litigation will work out is clearly not a very good lawyer. I do think that the reclassification sort of debate, which from a provider perspective, is like going back to the future. People have sort of skipped over what does reclassification mean for this particular set of issues, and I think there's sort of some assumption that. Reclassification potentially empowers the FCC to ban prioritization. I actually think when it comes to prioritization, reclassification, despite all its other warts, is really not much of a threat to prioritization. I mean, when we lived for decades in the Title II world and all these legacy Layer 2 services like ATM and Frame Relay, they all had prioritization mechanisms with them that were all tariffed with the FCC. So the FCC has decades of precedent of, tariffs that were deemed lawful for the provision of prioritization. So despite all the other problems with reclassification, I actually think this is one issue where reclassification would land in a good place.
And you're in favor on record?
No, didn't you hear me talk about the warts?
This is the warts part here.
And the point that Hanks makes, just taking issue with something that Scott said, those are all Layer 2 and lower. And in fact, most of the fancy optimization has been done at those layers. And especially in wireless, with the fast recovery, the different aspects, it becomes very, all that fancy stuff to make the networks work better is happening at Layer 2.
Yeah, I have a follow-up question on that, and our journalist colleague here. Sorry, I can't see it. Hank described how AT&T gives privacy to government emergency telecommunications service GATS. Can you imagine either the FCC or Congress saying, no, you can't give that kind of privacy to that service? Priority to government emergency telecommunications service.
No, I don't want to speak on behalf of the FCC by any means, but no, I can't imagine that. But I will point out that the government has been woefully unable to deal with emergency services in general, writ large. I'm sure many in this room know that they sort of can't get their act together to deal with the spectrum issue to provide an interoperable public safety network. So I don't know if they get out of their own way with this particular issue, but I think the point stands that yes, there needs to be, you're getting at priority of certain services, and emergency communication is certainly one of them.
that means the network has to support priority, the capabilities have to be there. There are other people like hospitals and doctors that need it. I mean, it's just politically impossible to think that it will go away.
I was trying to think of the one easy example to explain benefits of priority. And actually, you can give priority without hurting anyone. The big change with modern applications is old applications only cared when the last packet arrived. Email is a file transfer program. When it's completed, the logo goes. Web pages are the same. Streaming media, the timing of the arrival of intermediate packets matters for the first time. So even within the same amount of space, you can actually rearrange the order to make sure that the stuff that's streaming comes in time and still not delay the last packet arrival 1 nanosecond. And so simply by the change in profile of doing that, by allowing prioritization, you can actually have your cake and eat it too. You can actually have the streaming media service work and still have the email arrive at the exact same moment it did before. And so these are the kinds of things we're thinking about. The other thing I'd say is there's a bunch of stuff we all agree should be prioritized. I was talking to the people that manage the University of Pennsylvania's network. They're strong believers in network neutrality. They prioritize public safety communications. They prioritize environmental controls. There's a whole bunch of things they use their network for, just because, and every network will prioritize signals about managing the network above everything else. Because the other thing, everything just comes down to a shuttering halt. And so there's a certain amount of consensus that this stuff has to happen.
Last question, and then we'll wrap up.
Liz Stanton at TR Daily. Is that? Professor Yu had spoken approvingly of Professor Jackson's proposal for redefining or setting a rule for network neutrality because it only would be kicked in if the carrier or the ISP were providing it to its own services. But doesn't that create a new problem in the clause or provision where you spoke of reasonable terms? Because in the version that's being proposed where it only kicks in regardless of whether you're doing it yourself, so that everybody pays the same for third parties. If everybody's paying the same for third parties, that's kind of a number the carrier is fixing. But reasonable when you're providing it to yourself, that seems to create even more of a old common carrier rate regulation world than the one without kicking in. Is that clear?
The thing that I think you don't want to accomplish through this is to pass a law or a rule that just protects today's best effort internet. Right? So if you wall off QoS into a managed service category, and you give exceptions to that, and you put in protections that some of the pronet neutrality people want to ensure that today's internet doesn't degrade, I don't think you've gained all that much. I think the goal should really be this vision that I gave here of widely available QoS to applications and end-to-end. And so the trigger for that, I think, is that the QoS is in the network. That's a carrier decision, right? Now, I think everyone's deciding to do it. So that trigger of saying that they use it for their own, I think will certainly happen. I think on that slide I had something about under reasonable terms. I have no legal background. Please substitute whatever legal phrase is best. So, section 202, I think has unreasonably discriminatory. Maybe that's better language. I'm sure other people will come up with better things. But the intent is level playing field. And I think the trigger of using it for their own QoS, therefore make it widely available on a level playing field is the right goal.
Well, I think the question identified one of the potential problems of Title II reclassification. Is there is actually a century-old jurisprudence of what is reasonable and unreasonable under Section 201 and Section 202. And if you bring it in within the statute, you're going to pick all that up or have to provide administrative law justification about why all those things don't apply, because we have history here. And we're picking up an old regime, we'll pick up whatever back, designed for a point-to-point, voice-operated, heavily managed network that's not consistent with the network we have today. And so it's, maybe it'll fit, maybe it won't, but if it does fit, it'll just be an accident. Second thing you said, though, is I do think that Professor Jordan Scott's proposal moves us in a useful direction. I do think there are potential problems, even if you have to offer it on a comparative basis to just the services you offer yourself. And I may be speaking for Hank here, but I think that doing that would make UVerse impossible. Because they use basically 18 meg, I think of the 30 meg pipe, or maybe it's 12, I can't remember, so a pretty significant proportion. And they need scale to pull it off. I mean, they have to have a certain amount of dedicated customers and all that to make it work. And on some level, it is the network neutrality nightmare. It is a single application from a single provider being prioritized over everything else. But they will turn around and say that that's the $7 billion as opposed to $24 billion solution, which is important, for delivering all those services. We can make that choice. There will be consequences. And their ability to prioritize their own offerings is what allows them to do that. And we know that there are problems with people doing over-the-top services to try to make that work in a way that's decoupled from the markets.
I'll just briefly say, there obviously are complications, and so today in the enterprise space, there are strict ratios of traffic that customers can put in different classes. And similarly, we obviously couldn't have, massive file transfers in the voice over IP queue, because from a capacity perspective, the network hasn't been engineered to handle massive file transfers in the voice over IP queue. So that would all have to be worked out. I actually think from a business perspective, those issues could be worked out. I'll just say AT&T, I don't know what the right word is, but we certainly have never had any interest in offering QoS services on an exclusive basis. Our problem today is no one on the internet would want to pay us for QoS on UVerse because it's not end-to-end. If you're on the internet, what you need is end-to-end. Buying UVerse QoS works for us because we just have from the video hub office to the end user prem.
I think we could do this for at least another hour. I find this is a great panel. I think very, very enlightening. But unfortunately, we're going to have to stop and then go over to TPRC and hear this all over again. But a couple of thoughts, which moderator prerogative I could say. One is I think we need a new movement, which is I want my QoS. Maybe we could have buttons and hats and T-shirts, because I want QoS so I can talk to my son, or see my son. If my daughter, who's 4, won't talk to him on the telephone, she'll only talk to him on video Skype. When he's on the telephone, she won't talk to him. So I definitely have to have that. Last point I'll just quickly make. I'm struck by Scott's point about the fears that some of the public interest advocates have. And I don't mean to dismiss those fears. I mean, it's important that there are public interest groups that raise those fears. But I think historically what we've seen, I've been doing this for 15 years in Washington, and historically you see this with all sorts of IT applications, RFID, smart IDs, electronic voting, QoS, that the public interest advocates, because there's fear of abuse, they default to let's ban the technology. And then we are 100% assured that it will not be abuses. There also won't be benefits. And I think really to me, what this panel said or showed was there are enormous benefits. We can do this, we need to do this, and we need to think about a regime in which there are not going to be significant abuses, and as Chris talked about, where you have recourse if abuses occur, you have resource and they can be resolved efficiently. So with that, please join me in thanking really a great panel this morning, and I think they may have a few minutes for questions if you want to come on up. Thank you.